Hey, fellow mathematicians. Welcome to the podcast where math is figure-outable. I'm Pam.
And I'm Kim.
And we're here to suggest that mathematizing is not about mimicking or rote memorizing, but it's about thinking and reasoning, about creating and using mental relationships. We are all about empowering teachers and students. We answer the question, if not algorithms, then what? All right, Kim, so 2 weeks ago, we talked about the connection between fractions, decimals, and percents in episode 19. And then last week, we were playing with percentages in episode 20. And we had such a ball doing that. And we had great response from listeners that we decided to have this week's episode be focused on playing with percentages part 2, continued, because percents are figure-outable. One of our listeners, Kim Axtell, sent us this email this week. Just wanted to share that I totally just found 24% of 88 with my head and without paper or calculator and pretty quickly. Thanks. Great, Kim. So super glad to hear from that Kim about how she learned from our episode last week about playing with percentages. Let's play some more.
Actually, we also heard from one of your Journey members, Kathy Campbell. And she said, I don't want to give it away, but as I'm listening to the questions you're asking each other, I hear the second to last question. And I predicted that you were going to make a connection to a previous question and discuss a possible strategy, but you left me hanging. And then you closed the podcast with make a comment if you figured out our favorite strategy. And I figured out what you were up to. So that was fun to hear from Kathy. So just like last week, today we're going to actually do some math. So if you're right now going on a walk or you're, on the elliptical, we think you'll be able to hang with us. But if you can, grab a piece of paper and something to write with. Maybe just have your finger ready on pause so that you can do some math with us.
All right. So last week, we talked through a bunch of percent problems. But they were actually all the same type. So this week, we're going to work with all three types. So in a percent problem, there are three values involved. There's the total, there's the percentage, and then there's the part, the sort of part of the total that you're finding. So if we talk about three different kinds of percent problems, it's because one of those parts is missing. So one of the values is missing, and those are the three different kind of ways that we can ask about percent problems. The first type is all about finding the percent of a number. So if we start with the total, then we find the percent of it. And we talked about these last week. Like, for example, finding 12% of 50 or 50% of 12. We did that last week. And 45% of 10 or 10% of 45. So those were some of the problems we did last week. Let's do a couple more like those in case you didn't get a chance to listen last week, or you just want to have more opportunities to build some percent sense. All right, Kim, so you ready? You're on first.
Sure. Okay.
Okay. 18% of 20. What is 18% of 20? We don't want to hear what you're thinking.
Okay. So here's what I'm thinking. If I need to find 18% of a number, any number, I could find 10% of that number and 5% of that number and 3% of that number by finding 1%, scale up to 3%. But for this one, I'm thinking 18% of a number. Oh, I could also find 20% and then back up. So that's what I'm going to do. I'm going to find 20% of 20. And what is that? 4? 20% of 20 is 4. But then to find 8%, I've got to go back 2% to get to the 18%.
I'm actually going to back you up just a minute. How do you know what 20% of 20 is?
So 20% of 20 is, that's a fifth. 20% of a fifth. So if I want to think about 20 divided by 5, then that's 4.
Gotcha. Okay. So 20% of 20 is 4. And how's that going to help you find 18%?
So if I know 20%, then I can back up 2% to get to the 18%. And since I already know 20%, then 2% is really nice because I can just scale down from 20% to 2%.
Because it's like divided by 10. Okay.
Right. So if 20% was 4, then 2% is just going to be 4/10 or 0.4.
Nice.
So that's just 3.6. 18% of 20 is 3.6.
Because you went back 2% from 20% and 4 subtract 4/10 is 3 6/10. Nice. All right, cool. Totally figure-outable. Excellent. And that's what mathematicians do, right? So you just heard Kim have one attack where she could have found 10%, 5%, and 3% And that's a way to get 18%. But for this particular problem, she's like, actually, I'm going to go ahead and find 20% and back up 2%. And mathematicians do that. They think, they decide on a course of action, they rethink, and then they might choose which one like feels the best to work with that day. Very cool.
Right. Okay. You ready for one?
Yes.
Okay. All right. What if you were asked 20% of 18?
20% of 18. Okay, so my plan of attack is going to be to find 10% of 18
Okay.
and then double it to get 20%.
Okay.
So 10% of 18 is 1 and 8 tenths, or 1.8.
Okay.
10% of 18, 1.8. But I want 20%, so 20% is double 10%. So I need to double that 1 and 8 tenths, or that 1.8. And so double 18, I know, is 36. So double 1 and 8 tenths would be 3 and 6 tenths, or 3.6.
Nice.
Yeah?
Right.
Okay,
well
cool.
done. So the first type of percents problem is finding a percentage of a number, like 18% of 20 or 20% of 18. So Pam, if that's the first type of percentage problems, let's talk about another one.
Okay, so we could also think about, the first type is finding percents of a number. We could also find the percentage. So if we're given the total and we're given the part, then we could find out what the percentage is. Or if we're giving the part and the percentage, then we could find the total. So let's work first on the part where I'm going to ask you for the percentage. We don't know the percent at this time.
Okay.
So like if I were to say, we're going to start with 20. And I said, hey, 20 is what percent of 20?
Okay, let me wrap my head around for just a second. 20 is what percent of 20? That's just going to be 100%.
Yeah, because 20 is 100% of itself, right? 20 is, okay, good, very good. Okay. 10 is what percent of 20?
10 is just half of 20. So that's going to be 50%.
So 10 is 50% of 20. Very nice. Okay, good. What about 5? 5 is what percent of 20?
5 is what percent of 20? So 5 is going to be 25% of 20. So 10 was 50%. So 5 is just half that. So that's going to be 25% of 20.
Cool. And another way you can think of that is 5 is a quarter of 20, right? Because 20 divided by 4 is 5, and a quarter is 25%. Okay, cool.
Okay.
Ready? We're still focusing on 20 here.
Okay.
15 is what percent of 20?
Nice. So 5 was a quarter of 20.
Mm-hmm.
So 15 is going to be 3/4 of 20, or 75%.
Nice. Okay, cool. So 15 is 3/4 of 20, or 75%.
Right.
I'm back in fractions. So we want to stay percents today. Okay, cool. All right. So staying with that whole of 20, that total of 20,
Okay.
1, the number 1 is what percent of 20?
1. We just said 10 was 50% of 20.
Mm-hmm.
So I'm gonna scale down. So if 10 was 50%, then 1 is just going to be 5% of 20.
Interesting. You got any other ways of thinking about that?
Yeah, actually, I was just talking about coins with my son the other day. And so I know that there are 20 nickels, and there's a relationship for me about 20
and a dollar.
And a dollar. Yeah.
Mm-hmm.
I could also think about if we said 5 is 25%, then you could scale down by 5.
Oh, nice.
So 5 is 25%, then 1 would be 25% divided by 5. So that's 5%.
Very cool. Very cool. I like the nickel one. That's really cool. 1 out of the 20 nickels would be 5, like 5 cents or 5%. Cool. All right. So how about 2? 2 is what percent of 20?
Oh, good. I'm glad you just asked me about 1%, or 1. So 1 is 5%. So then 2 would just be double that, 10%.
Cool. You got any other ways of thinking about that?
2. What else have you asked me? Oh, yeah. So 100% is 20. You just asked me about 20. So scale down a tenth of that. So a tenth of 100% would be 10%.
Nice. Very cool. Now, we use some numbers here that are pretty reasonable, pretty figure outable, but we can get pickier. We could get into some gnarlier, uglier numbers, but probably not on a podcast. Like we would have to, I would want to use a percent bar where I would put the information down that we know, and then I would chunk things and write other things I can figure out. And I can get really into some pretty gnarly solving problems, either the first type that we just did or that we did today, or the finding the percentage, either way, if we wanted to get a little pickier. But we would just want to use relationships like we just did, and we would just have to, keep going and get a little bit more precise. All right, cool.
Can I ask you some?
Yep, I'm ready. I'm ready.
Okay, all right.
Okay.
All right, so let's work with the number 12. You gave me 20, we'll do 12.
Okay.
So 6 is what percent of 12?
All right, so 6 is half of 12, so it's 50%. So 6
right.
is 50% of 12.
Yep, good job. What about 3? 3 is what percent of 12?
Okay, so 3 is a fourth of 12. That's one way to think of it. So that's 25%. But it's also half of the 6 we just had. And 6 was 50%. So 3 is half of 50%. 3 is half of 6. So half of 50% is 25%. So 3 is 25% of 12.
Excellent. All right, let me go with 1.5. 1.5 is what percent of 12?
Whoa.
Sorry about that.
You big meanie. Okay, hang on. So if 3 was 25% and 1.5 is half of 3, then I want half of 25%, and that's 12.5%. Okay.
Yeah.
So 1.5 is 12.5% of 12. Woo.
Nice. Okay.
Weirdo.
One more. Let's go
Okay,
with 4.5. 4.5 is what percent of 12?
Kim. Okay, I can do this.
You can do it.
Okay, so we already know that 3 was a quarter of 12 and 1.5 was 12. It's almost like I feel like I'm dealing with eighths here, because that 12.5% is like 1/8.
Mhm.
Anyway, it's just sort of feeling like it. So once I add the 3 and the 1.5 to get 4.5, I'm thinking about 25%, and 12.5%, that's 37.5%. Yeah, I'm definitely thinking in eighths here. That's interesting. So 4.5 is 37.5% of 12, or it's also 3/8 of 12 if you want to go that direction.
Well done.
Thank
Very
you.
good. All right. Let's talk about that third type of percent problems.
Right. Okay. So the third type, the one we haven't talked about yet, is where the total is unknown. So we know the part, we know the percentage, but we don't know the total. And these might be the most challenging for me.
Okay. Give me an example. Let's see if I can handle
You can do it. You can do it. All right. So let's use 20 again.
Okay.
What if I say 20 is 100% of what number? We don't know the total. 20 is the part. It's 100% of what number?
20. Okay. That one's good. 20 is 100% of 20.
Because it's just itself, right?
Sure.
20 is 100% of itself. Okay, cool. You thought these were going to be hard. 20 is 50% of what number?
20 is 50% of 40. So 20 is just half of 40. I got it. Okay.
Okay, cool. So 20 is, yep, good. That works. Okay. 20 is 10% of what number?
20 is 10% of 200. I can just scale up times 10. So yeah, 20 is 10% of 200.
Because if you know 20 is 10% of a number, that number's got to be much bigger than 20, right?
Right.
And like you said, it's going to have to be 10 times bigger, because we're talking about 10%. Cool.
Yep.
So 20 is 10% of 200. 20 is 5% of what number?
Ooh, it's going to be a pretty sizable number. So 20 is 5%. So I want to go from 5% to 100%. So I'm going to scale up times 20. So 20 is times 20, 400. 20 is 5% of 400.
Because 5% of 400, you could think about that. That's 20. Yeah, cool.
Yeah,
cool. All right. See, these aren't too bad, right?
Not bad. All right,
Can you describe what was going on in your head a little bit with these a little bit differently?
Yeah. So I actually thought about that last problem 2 ways. So I had already said that 20 is 50% of 40.
Mm-hmm.
So now there's a relationship between 50% and 5%.
Ah.
So I have a tenth of the percent. So I need 10 times greater of a number.
That blows my mind just a little bit. So if 20 is 50% of 40, then you're thinking 20 is 5% of a much bigger number.
Right.
How much bigger? 10% bigger.
Right.
So 10 times 40 is 400. Interesting.
Yeah,
Okay,
yeah.
cool.
Okay, you want to go?
All right, bring it on.
Okay, I'm going to ask you the same questions, but I'm going to give you a crunchier number, okay?
Of course.
All right, so we did 12 last time. Let's do 12 again.
All right.
12
all right.
is 100% of what?
That's easy. 12 is 100% of 12.
Okay.
Ha!
You can do this. 12 is
I can do
50%
it.
of what?
So 12 is 50% of something. It's half of something. So 12 is half of 24. So 12 is 50% of 24.
Okay. 12 is 10% of what?
Okay, if 12% is 10% of a number, then the number's big and it's going to be 10 times bigger.
Right.
And so 12 times 10 is 120. So 12 is 10% of 120 because now I'm going to think the other direction. If I have 120 and I want 10% of it, yeah, that's 12. Okay. Yep.
All right. What is 12 is 5% of what?
Okay, so this is going to be a bigger number because if 12 is 5%, then 12 is 5%. It's 5% of this big number, right? Because it's just 12.
Mhm.
12 is just 5%. 5% is like, so I could do a couple things. I'm actually tempted to say if 12 is 5%, then I know that double that, 24, is 10%. And so if 24 is 10%, then I can multiply that by 10. And so that's 240. So 12 is 5% of 240.
Nice.
Yeah, that's one way. And then I'm going to try your strategy because this is not as natural for me. I know that 5% is like a nickel and there's 20 nickels in a dollar. So I could, if 12 is 5%, then I could scale the 12 up by 20.
Mm-hmm.
So I could do 12 times 20. And since 12 times 2 is 24, 12 times 20 would be 240. So 12 is 5% of 240. Right? That's your strategy. Okay.
Yeah.
Bam.
Okay, I'm going to
Okay.
actually give you one more.
Thanks a lot.
12.
No, I like it. Playing is good. Playing is good.
It is good. 12 is 150% of what?
Wow, that is, we haven't done any that are over 100. I guess
No.
it's time that we did 100%. Okay, good. All right. So 12 is 150%. So this is different than all the other ones we've done in this last little bit because now if 12 is 150% of something, it's bigger than the sort of total. It's bigger than the referent that we're referring to. So 12 is like 3 halves. That's kind of actually how I'm thinking about it. I'm thinking about it like 3 halves is 150% is like 50%, 50%, 50%. So it's like 3 parts of the original. And so if I cut 12 into those 3 parts, that's like 4 is the part, but I want 2 of those parts to get the whole 100%. I don't know if that's making any sense. And so 8. So 12 is 150% of 8.
Nice.
Yes. Yeah. How do you think about that way?
I did actually. I was following you because it's exactly what I was thinking about.
Okay. All right. Cool. Because if 100% of 8 is 8, then 150% of 8 would be another half of it, which is 12. So yeah, 12 is 150% of 8. So I just kind of went backwards to sort of check and make sure that we're good. Okay, cool. So this is interesting, right? Because traditionally, typically, if you look at a typical textbook or a traditional classroom, we tend to see teachers kind of use only one way of thinking about percent problems. And I typically see 2 main sort of one ways of thinking about percent problems. One way is that teachers will say, if it's a percent problem, set up a proportion, put the part over the whole equals the percent over 100. And then cross multiply and divide, and you can solve for the part that's missing. And so what happens is kids like do the same thing every time. All they have to do is figure out, do I have the part? Do I have the whole? Do I have the percent? Put it in where it goes, and then solve for the missing thing by using kind of multiplicative reasoning, cross multiply and divide, or hopefully at least multiplicative reasoning, or maybe not even that if they're using an algorithm or a calculator at that point. But my point is they sort of do the same thing every time. That's one traditional way. Another traditional way is that they turn the percent problem into an equation. This is a typical algebra kind of solution. Maybe the proportion one might be a typical middle school kind of solution. But the same thing happens if as soon as I turn it into an equation, then I kind of write everything down like x times the percent equals the total or something like that. And then I kind of solve for the missing part, and I use equation solving techniques to solve for the missing part. But I'm kind of doing the same thing every time again. I'm putting in what I know, and then I'm sort of solving for what I don't know. What I'm not doing is actually making my brain think and reason about the percents.
Right.
I'm either translating it into a proportion or I'm translating it into an equation, and then I'm solving the same way every time. What I'm not doing is really thinking about what do I know and how does that relate to, how do the pieces relate to each other, so I could figure out the missing part. And then that actually like makes my brain be able to handle more and more complex relationships. So it's an interesting, this is a perfect moment for us to think about what we're advocating in math education that's different from traditional, because traditional says, just do this one way and do it the same way every time and practice it until it kind of gets this go to, and I've got this like, and people call that sometimes procedural fluency, and that's not so much what we're interested in. Do I want students to be fluent? Absolutely, but I really want them to be fluent in thinking and reasoning and using relationships. I want their brains to get more, to be able to handle more and more sophisticated things. Or by the time we get them in later math, all we can do is say, oh, well, your brain isn't ready to handle all the sophisticated stuff, so we better just give you rules and stuff to mimic and procedures to follow all the steps, because that's all they can handle. And we don't want that, right? We want to build brains. We want to empower people to be able to think and reason using what they know, and then they can handle more and more crankier problems. All right, so let's recap a little bit. There are 3 types of percent problems that we mentioned today. One is where the part is unknown, one where the percent is unknown, and one where the total's unknown. Every time, ask yourself what you know, and then use friendly relationships to solve for what you don't know.
So much fun today. Hey, don't forget to join us on Math Strat Chat on your favorite social media on Wednesday evenings. Thank you guys so much for the 5-star ratings on Apple Podcasts. We have loved reading comments, and we really appreciate you posting them.
So, if you're interested to learn more math and you want to help students become mathematicians where they mathematize their world, then the Math is Figure Outable podcast is for you, because math is figure outable.